ABCs of intercooling. Now, back in the day when we're talking about the old GMC root style blowers, the intercooling really wasn't a thing. I mean, sometimes on the bigger blowers they throw an intercooler on there, but generally speaking, the boost was just lower. Now on today's modern vehicles, we're throwing high boosts, we're getting high horsepower numbers, especially when you're talking about turboing. Intercooler matters. So you're going to want to watch this video and just understand what's going on so you have a pretty basic idea of what you're looking at, what you're looking for, and how it applies to you. So let's get into it. To the Jumbotron of knowledge. Today we're going to be explaining intercooling. You need this for forced induction. You really do. You want to boost smarter, not harder, hotter. So this is your basic design of an intercooler. You have your hot turbo gases coming out. This is going to get really hot from compressing the air. From what I understand, it's typically about 10 degrees per 1 pound of PSI you throw out. So if you throw out a 150 PSI or 150 degrees, you're probably throwing out about 15 PSI. Now it even gets hotter from the turbo because it's coming from the exhaust side. So that's going to bleed a little bit of heat over there. You need to cool this shit off. So it's going to go through the intercooler, it's going to cool off, and then it's going to come into the intake. Basically, hot air comes in, the air goes through the intercooler, and then the cool air comes out. Pretty simple, right? Why intercooling matters. So it all comes down to air density. As you heat air, it's going to expand. This is a terrible diagram, but it's going to work for the purposes. We're going to pretend that these are oxygen molecules. As you warm up the air, the oxygen molecules spread out. You don't need air to make power, you need oxygen to make power. So think about it like this, like if I take a plastic bottle, no pressure on it whatsoever, the bottle's completely full, I put the cap on there and I throw it in the freezer. When I pull that bottle out, the bottle's going to be collapsed down. There's still the same amount of air in there, but now I have more room to put even more air inside of there. Same with reverse. If I take that bottle and I put it out on a hot sunny day, yeah, when I closed it, it was at zero pressure. Now it's been sitting in the sun. When I open it up, it'll go psh. That means the air's expanded out. It's still the same amount of oxygen in there, but it's taking up more room. You want to compress that down into a smaller package. This way you can fit more oxygen inside of your cylinder. The heat is bad. The heat's working against you because it's trying to spread it out. So it can give you even phantom PSI. Not good at all. Plus you can run into detonation, but the ultimate goal here is air density. That's what we're trying to do. We're trying to get more oxygen molecules in a smaller space to build more power. Oh, why quality matters. If you wind up going with the cheap air, like eBay intercooler, you know what? You're going to have high pressure drops. You're probably going to have leakage. It's going to be poor efficient. It's not going to be very well built. A reliable turbo is going to have a low pressure drop. It's going to be extremely reliable. It's going to be efficient. I'm going to go a little bit more on the actual construction of it to understand why you want to kind of avoid these cheaper intercoolers. Now for sizing, it goes out a little something like this. You know what? 1.5 to 2 CFM per horsepower. So this would break down, you want about 150 CFM for 100 horsepower. Now you're going to want to leave yourself a little bit of headroom, so always go just a little bit bigger. I mean, you could go with your exact needs, but boost is addicting. You're probably going to crank it up a little bit, so give yourself a little bit of headroom. If you're looking for, 500 horse, maybe get an intercooler that can handle 600 or 700 horsepower. That's not a bad idea at all. Size, once you get overboard, you are going to run into weight problems. It's going to get heavy. I mean, does that weight problem affect you? You got to look at your independent build, but you're going to have so much area too. So yes, you can go overboard, but it's always better to go just a little bit bigger than it is smaller. Now, if you go way overboard, obviously you're going to get boost loss and stuff like that. We'll talk about that in some future slides here. This is the general how it breaks down. So 1.75 inch diameter, that's 285 horsepower, all the way up to a 5 inch diameter, that's 2,300 horsepower. Here's the CFM for horsepower that you should have. So say we're doing 700 horsepower, you should have a CFM of 1050. Now when you select your intercooler, lean on the manufacturers. Go with a quality manufacturer. You're not the first person to turbocharge your vehicle. You're not the first person to supercharge your vehicle. You're not the first person to throw out a centrifugal supercharger. All this math has been figured out over and over and over again. Don't reinvent the wheel. Call them up, be like, hey, this is what I want to do. This is what I got for parts. This is the kind of car I got. What intercooler do you recommend? And they'll be like, all right, we have this part number right here. This does fit in that size horsepower, and it is that size car, and it does handle that much horsepower. So do not be afraid to lean on the manufacturers. Go with the brands. Like, pick a reputable manufacturer like Garrett or something like that, or any one of them, really. Like, just a quality manufacturer. Call them up, tell them what you got, and they'll tell you exactly what size you need. Now, it's kind of cool looking at the charts. This way you can kind of figure it out in your head to plan things out, but there's no need to figure out the math yourself. Don't reinvent the wheel. The wheel's already been invented. It's already been proven. The research and development's already there. Call them up, tell them what you got, and they're going to tell you what you need. All right, so here's a couple of different names. Now, intercooler is actually incorrect terms. So you got air cooler, or charge air cooler, CAC. That's probably a more accurate word of what we're talking about here. This is just cooling down the heat charge. Intercooler, that's between two turbos. So if you have a sequential setup, you have one turbo like a smaller turbo powering a bigger turbo, the intercooler in between it, it's in between the two turbos. Aftercooler, which is also a correct name, that is after all the boost is done, right before the engine. Or turbo cooler. That's another term that gets used a lot. So here's a diagram. So this would be an intercooler. You have one turbo, which is terrible. This is the only this crappy diagram is literally the only diagram I could find on the internet to show what I'm talking about here. And when I tried to have the AI make one, it just got all types of crazy. Anyway, you have one turbo, then you have an intercooler, and then it goes into the next turbo, and then into the engine. Or even possibly an aftercooler. An aftercooler, you got the exhaust, you got the turbo, you got the aftercooler, or charge cooler, or turbo cooler, and then intake manifold. Now, what's the deal with these names? Look, if somebody calls you out on calling it the wrong name, one, their car isn't cool enough to where they have to try to flex on how smart they are by using terminology because their car as a whole doesn't consume the conversation. Number two, they probably smoke vapes, and they probably drive Subarus, and they may or may not be lesbians. So, we call it an intercooler. That's common knowledge. That's common usage. Don't go around correcting people because you make yourself look like a retard. It's their build. They built it that way. They can call it whatever the hell they want. And if they're worried about what it's called, they probably have a shitty build that probably has less than 300 wheel horsepower, aka a Subaru. All right, so the two different types of coolers, what are we looking at here? We got tube and fin, and then we got bar and plate. They each have their purposes. So a tube and fin, this is typically what you're going to see on the street. Because a tube and fin has a lot of air that goes through it constantly because you're always up to speed, it works efficiently, it's lightweight, it's easy to manufacture. A bar and plate, this is ideal for really high boost drag racing because there's a lot of mass there. And you're sitting at the light, waiting for it to change, like, what? Like you're creating a whole bunch of heat, but no air is moving through that. So you're using the mass of the intercooler itself to soak away some of that heat before you get going. Now the draw-off is, this is going to hang on to that heat a lot longer. It's not going to cool down as fast, so it's going to take longer to get heat soaked, but once it gets heat soaked, it's going to stay heat soaked. And again, it's going to weigh more. So for street use, it's ideal to go tube and fin. Yes, these can get heat soaked a lot faster, but when are you going to be sitting at a stoplight for like 4 seconds at 35 PSI just generating boost? This is not going to happen. You're going to be moving. Plus, we all have radiator fans, so there's still going to constantly be air going through because it's sucking through the radiator, so it's also sucking through the intercooler. Tube and fin is basically what you want to go with on the street. This is what they look like right here. So this is the bar one. As you notice, it's got a lot of mass there. There's a lot of design there to help leach off the heat and put it into the system itself. And then once you get moving, the air comes through and cools the system down. Here's what it looks like. Your air would come through like this. the air moving through the vehicle would come through like this, and it's got all that material to deposit heat into. Here's your tubes. Looks like this right here. Your air would come through just like a standard radiator, like what you see on a car, like your liquid cool radiator. The air would come through these tubes. Now the air as you're driving comes through like this, and it's going to cool it off. Each one is an individual tube. Like, yes, you see these lines right here, but here's your tubes going this way actually. So it could be either way. I mean, I don't know which way it's looking at it because that's the diagram. So this could be your tube going this way, or these could be your tubes right here. I'm assuming these are probably your tubes right here. Either way, this is the point. No matter which way you're looking at it, this is basically what it's going to look like. Actually, your air is probably going through like this because the tubes would have more of a rounded edge if we were looking at it from this direction. So, now we got the turbulizers. I'm sorry if I'm pronouncing that wrong. It's just a word I don't normally use, and I practiced pronouncing it before this video, and I kept screwing up. So we're just going to call it turbulizers. Hopefully that's close enough to the actual real word. So this goes inside the intercoolers. You will see these on your higher-end intercoolers. If you buy an eBay one, you're probably not going to have them. But on any other like main brand intercooler, they just put it in there because it increases the efficiency. Otherwise, what you're going to get is lazy air, and it's going to have poor heat transfer. The air is going to come shooting through the intercooler, through the tube. Yeah, the outside of the air is going to cool down a little bit, but the stuff in the middle is going to be at a higher velocity, and it's going to carry the heat. So it's going to have a real poor job doing that. So what they do is they put a bunch of brakes in there to make turbulence. This way the air touches the actual material and bleeds off the heat. This is what they look like right here. You have your tubes, and these are the I can't pronounce it. You read the word, so you know what it is. These go inside of the tubes, and like I said, they just create turbulence to break that up. They come in a bunch of different designs, like this right here. Every company's probably going to have a patent on their design that works the best, and they're going to claim their design works the best. But essentially, it's just to create turbulence and not let the air just slide through the center at super high speed and avoid touching the outside and coming out just as hot as it basically went in. Now, when you may not want those is at very low boost levels. If you have a very efficient, you're already like, it's super efficient, you're going to be at a top speed, high RPM setups. If you're looking for maximum flow, yeah, you take those out of there. This way you can get maximum flow, but you're going to want a more efficient. You've basically decided that, look, the little bit of heat it's going to bleed off. I shouldn't say a little bit. The heat it's going to bleed off is not going to be a positive enough gain to reduce the flow going into the engine. All right, so now we got your intercooler. Should you go sideways with the air, or should you go top to bottom? What you want to do here is you want to pick the longest path. So depending on your setup, that matters. This is always the best way to do it, but generally speaking, for commercial vehicles at least, you're going to want to go sideways, cross flow. For example, look at on the semi. This grill is pretty square. It doesn't really matter if he goes from the top to the bottom, or if he goes across, or which direction he chooses to go, because it's pretty much the same distance. He's pretty free to pick on what he wants. For a car, as you notice, the grill has substantially more room going this way. So let's pretend you flowed from bottom up. The path from here to here is much shorter than the path from here to here. So this is typically how you want to go. Now sometimes they might even do it in two strips, like it goes through like this, and it comes back around, and then it comes back out this side. They have a whole bunch of different setups, so you can pick it custom to your setup. Same with the truck. The grill is obviously longer than it is taller. So you have to look at your application. Now, if you run it on top, like say you're using an off-road vehicle or something like that, and you got it mounted in the roll bar with an electric fan on it, well, then it doesn't really matter. So you're just looking to have it go through there and go through the maximum amount of space. When do you choose an intercooler? Under 5 PSI, don't even worry about it. Like the heat sink and that, because say you're idling with a 5 PSI turbo, well, it's going to ultimately warm up that intercooler a little bit. The gains you're going to get at like 5 PSI or lower aren't really worth it. But the fact of the matter is, are you going to be running 5 PSI on a setup you spent thousands of dollars on it? Absolutely not. Nobody's going to be running 5 PSI. It's just like an obsolete PSI. We don't do that anymore. We're always like 10 plus, regardless if that's like a supercharger or a turbo or whatever you're going to go with. 5 PSI is the olden days when we're trying to make cast pistons be able to handle boost. We're not going to be running 5 PSI because we're men and we're from America. So at 7 to 10 PSI, which is what we call beginner level, you're going to want to run an intercooler because you are going to get an advantage. You're going to get more dense air, and that goes for superchargers or turbos. Doesn't really matter. Once you get up to like 10 PSI, yeah, you need to start really looking at intercoolers. Now, you are going to get a loss in pressure, right? Ideally, they like to keep it under 1 to 2 PSI. The more complex tubing you have and the more channels it needs to go through is going to increase this loss. Especially if you have inefficient intercoolers like stuff from eBay and stuff like that, and you have a bunch of hard 90-degree turns, yeah, the losses are going to start compounding up. You may wind up at like 4 or 5 PSI of loss. I don't know. Plus, with the eBay intercoolers, they may even leak a little bit of pressure. There's in the fleet world, there's acceptable a small amount. I forget what the actual term is for it, but they do have a little bit of leakage, and they let that go. But you're still going to get a loss just because of the directions it has to take and the velocity loss. It just happens. Ideally, though, again, we're going to want to operate in the 1 to 2 PSI of loss. So if we measure at the compressor and we measure at the intake, there's only going to be a 1 to 2 PSI variance. All right, so these are the different types of intercoolers. We got air-to-air. That's what you're commonly going to see on turbocharged vehicles. You're just going to have an intercooler in front, and it's going to cool the charge by having airflow through it and bringing it down to ambient temperature. Then you're going to have water-to-air. This is what you're going to see inside of superchargers like Hellcats, stuff like that. Underneath the intake, underneath the blower, there's going to be like a little mini radiator, and that little mini radiator is what they're going to use to pull off the heat, and then they're going to have another little mini radiator in front of the Hellcat that's going to cool off that water. Now they do have some exotic designs, like for example the Demon that uses air conditioning to cool it down, which is pretty awesome. I was actually looking into this in the early 2000s because on the Jimmy, I read one of those supercharger books. It's like, oh, you need to go the smallest supercharger you can and just overdrive the shit out of it, because that was our understanding back then. Because YouTube didn't exist and there wasn't counteracting opinions, I took it as it was written in the Bible. So I went and got myself a little Wien 142. I overdrive the shit out of that. I took the 3-inch pulley down to 2 3/4, and then the bottom edge pulley from 6 to 7. Ultimately achieved 9 PSI, but that thing was a flamethrower in the intake. I would literally like feel the power just bleed off as the RPMs increased. It'd have great power down low. By 3 grand, I could start to feel it was losing power. By 4, it was really losing power. By 5,500, there was no power left to be had. So I'm like, well, I should just take an AC pump and run AC through that and counteract that. Well, everybody I talked to in the heating and air conditioning world was like, oh, you can't generate enough AC to handle that much CFM, so you're just being stupid and don't worry about that. Apparently, in the Demon, they figured that out, or those guys at the AC people didn't know what the hell they were talking about. Either way, that is one of the what would you call that, exotic coolers. Now, they do also have in drag racing where they'll have like an ice bucket almost. It's an ice tank, they throw ice water in there, and it's a water to air exchanger, and they get it as cool as possible. Not practical for normal driving, because are you going to stop every like 10 miles and fill your ice bucket back up? No. For practical driving, for turbos, you're going to be looking at an air-to-air. For superchargers, you're going to be looking at an air-to-water, just a standard radiator inside of there, pulling that heat away from there. Anyways, appreciate you guys watching my video. I hope it was entertaining, if not even a little bit educational. If you'd like to help support the channel, the best way to do it is click on that Amazon affiliate link down in the description. Even if you don't buy what that link is for, just clicking on it, doing the Amazon shopping you were already going to do anyway, I'll kick back for it because you came there off my channel. Thank you for watching. Don't forget to subscribe.